Thank you for coming. This is our 47 meetup session, San Diego CPP meetup. This is going to be a 1 hour meetup. I have kind of a hard stop at 6, so so I have lots of small, kind of smaller bite-sized topics that I think we can learn a lot. We'll have the CPP quiz and all of that, but there are a few topics that I've kind of like few slides each, and they cover a specific topic each. So I'm planning to have it about 1 hour, and yeah, it is recorded. And feel free just to stop me anytime if you have any questions. Start. So I'm already sharing. I'm just gonna turn it into a presentation view. So I don't see uh, the other screen of MS Teams. So if you have any questions, just feel free to just stop me. Okay, this is fine. It's supposed to be very interactive. If you're first time here, thank you for joining. I'll explain what we're doing and what is the goal of the meetup. Um, so this is the agenda. It's the full agenda. I'm not sure I'll have time to cover everything. Pretty much I won't, but I won't be able to do that, but that's fine. We'll do it next time. It's gonna be next time. Next time, Amir Kirsch has a new talk that he he presented in the New York uh, CPP meetup, I think a few weeks ago, uh, and he would present the same on March. I think it would be 21st. I think I can remember exactly, but something like the second or third week of March. I think it was the 21st. So I'll have the announcement very soon. We'll talk about jobs at Qualcomm. There is one posting that I would present. CPP quiz and other things that you see here. We'll take it one at a time, so don't worry. So if you're new member, we are discussing all kinds of topics that usually I'll come up with, and if I have some luck, I'll bring someone external to speak. So we had Amir Kirsch a few times, and Jeffo came here and had everything is virtual for now. And if you want to present, by all means, just feel free to ping me and anything that you can think of. I I just in the past every few days I'll collect few items that I've seen on the web or just had just bumped into, and I wanted to dive more, and it's easily few slides. So I bet you have the same when you touching C++. So feel free to do the same if you want to, and let me know. It can be from 5 minutes to anything to an hour. So it's really kind of free form. So feel free to do that. It is the meetup quiz are sponsored by Qualcomm, the wireless research software, which uh, the VP Charles Bergen is donating the meetup fees every 6 months. So thank you, Charles, for doing that. Much appreciated. We do have a Dropbox link that I would upload my slides. Um, we have a Slack channel where I uh, would announce any sessions, and we have Discord, which I actually use the Discord more than Slack. Last time we had coroutines, which was like more than 2 hours long session. So and it's recorded. So if you are interested in coroutines, you can take a look at the recording. It is uploaded in the San Diego CPP Meetup YouTube channel, and we have a lot of sessions there. I do use SDCPP Meetup handle account in Twitter. I'm still on Twitter. I'm not. I haven't shifted into Mastodon or anything like that. This is my handle. If you wanna follow me for anything related to C++ and other languages and software engineering in general, Linux and so on and so forth. That's usually what I discuss on. So when I have time, I'll post blogs. I do want to post blog on core routines on my to-do list, just being very busy in the past few weeks. But this is my to-do list to do it. So Martin Robert is hosting me on his blog. So as you probably know, I usually have my meetups almost 100% of the time. It was on Tuesday, which was yesterday, and I was so usually when I have a meetup, I make sure that my wife is okay with that. There is no like anything that I previously committed to. So she would remind me, oh yeah, you can do it in this night because you need to do that and that. So I asked her what about Valentine's Day and she said no, people would not come. And I said, okay, I'll have a poll on Twitter. And apparently people didn't want to have it on Valentine's. So this is why we do it today and not on Tuesday. So that's the point. 105 people, 66 saying no. So no. Okay, let's start with jobs at Qualcomm. There is a group in Qualcomm that I'm working with that asked me to have that posted. So this is from the machine learning engineering, super interesting role. They had it as a C++. Yeah, here it is. So C++ wizard engineer. So if you feel like you're a C++ wizard engineer or you know someone that he or she is a C++ wizard engineer, please feel free to apply. This is the number of the rec. Please approach me offline if you need any more details. I just posted here the just a screenshot from their website that you can also access. I know the hiring manager, and also if you have any questions regarding that, this just approach me and I'll help you to get you connected to the hiring manager. Again, super interesting domain, super interesting project as part of the ML. It's all C++ and they need wizard, so they need someone that would do something very interesting. Okay, let's start. We start with CPP Quiz, and the idea behind CPP Quiz is that I find it very interesting to pull all kinds of new ideas and interesting stuff that each quiz would provide us. So this is the whole idea behind that. So what I'm going to do is switch to, I'm going to switch to the CPP Quiz. 1 second. And if you're new, you just need to shout the answer. You don't need to wait or anything like this. So feel free to do that. And I'll share in a second. Okay. So okay, if you're new to CPP Quiz, actually it's a great website to pass few minutes if you're waiting somewhere. It has an app, so there are 4 options. Either it's guaranteed to output, and we put here what is to output, and then compilation error, one option, unspecified or implementation defined, or the program is undefined. So take a few seconds and read CPP 17. This is the difficulty, and what is the output, if there is an output of this program.
So the first time it'll be 2.
Okay, it would be 2. Let's write it. 2.
2, then 1,
Then 1, and you'll need to
and
explain.
that's it. So x minus minus first will be x minus minus, which is 3 minus minus will be 2. And 2 is greater than 0. So we'll go inside the loop and actually print it. And then the value will be 2 minus minus, which is 1, which is still greater than 0. So we'll again go inside the loop and print it. And then we'll get out of the loop.
Okay, so remember that this is a post increment. So we get the original value, right? So
right. So in which case it'll be 3, 2, 1 then. Okay. Okay.
No. Wait a sec. So let's do it again. So you're saying if it was, so this is 3 and then minus, which means that we decrement that. So you're saying 3, 2, 1?
I'll have to look whether minus minus comes first in the precedence or the less than comes first or greater than comes first. Sorry.
I would say 2.
But we're not printing out the result of the increment. Is the thing to keep in mind, right? We're printing it out after the increment's taken place. So
after
the loop is evaluated based on
the loop is
what happens with
evaluated.
post.
The loop
Yeah,
is
so I think
evaluated.
the post increment is first.
So the loop is
it is 2, 1.
evaluated. Yeah.
2, 1,
It is
0.
2, 1, 0. 2, 1,
2, 1,
0.
0. 2, 1, 0. Okay. So
2, 1,
let's
0.
see. So let's see why. So it's 3 minus minus. But
2.
what happened is, yeah, but we get 3 greater than 0. But we print 2, right? When we on 1, we do minus minus, but the 1 is compared to 0, but it's 0 here when it goes here. So this is why it's 2, 1, 0, just like someone was shouting. This is explaining that. By the way, it's not the first time that I'm seeing this. X go to 0. It's not if I can remember where I had this opportunity to look at to see something similar, but it's like I'm not using it, but some people probably find it very amusing to use it. Okay, let's go to the next one.
I mean, I think it's a common idiom in some code bases.
Yeah, it is. I just can't remember where I saw that. I saw it like a long time ago. Okay. Take a few seconds. By the way, it's always CppQuiz 17. I don't think they changed it, but it's all according to CppQuiz 17 standard. And this should be easy. So we have class A. Class B has an integer in public, and X is initialized to 0. Okay. Then we have class C and struct D. Class C has public A, comma B, whatever it means, and then struct D has private A and then B, again, whatever it means. So one of the things that I wanted to highlight is access specifiers and access default access when we inherit. So class, the default access when we inherit is private. Struct is the other way around. Struct, the default is public. So for class, if we want to say, okay, we want this to be public, we need to specify. But if we don't say anything, it would default to whatever the class is, which is private, and the other way around in struct. So
I think it should be a compile error.
It's a compile error. Okay, why?
Because d.x is not accessible publicly.
Okay, let's see first why C is accessible. You're saying D is not. Okay, so C has public A, and A is here, and then has private B, right?
Oh, okay.
I'm just trying to read that. So it's trying to access X via B. Should not be possible.
I thought public A, comma B would be public.
I'm not sure, by the way. I'm not sure.
Yeah, I believe it's
X is a public member of B, which is the base class, which accessible does X. Okay, so let's take a look. I'm jumping to the end. So we didn't provide access specifier for B here. Class C derived privately
Okay.
from B. So if you want to say B is public as well, we need to specify.
Wow.
Struct derived publicly from B, but privately from A. We don't care about A. The A doesn't have anything. So the idea here, there are a few things, the few takeaways here. First of all, yeah, you need to specify this whole thing about, okay, comma, whatever, it's not carry over from the previous one. One thing. The second thing is just a reminder about the defaults when we inherit. By the way, the same goes with the access specifier. Like in struct, the members would be public. If you need private, you need to specify. It's the other way around with classes. It's default private, and you need to say public if you want it to be public. So it's basically the same. Okay. Okay, the next one, a bit more difficult. Again, CPP 17. Take a moment to read. Okay, let's take a look. So yeah, so Sam you said something?
I think there's a bit of a metagame with this question, where if it was only two or one of them, it would be possible to get the right answer without really knowing which one it was. So it would either have to be 3 or 0, and that means I think it's going to be 3 Fs.
I think word is not a valid type. Word pointer is, so I think it might be compiler error.
Okay, let's try with compiler because it's the easiest thing, right? Okay, it's not a compiler. Okay, now let's take a look what happened here. There is a struct S with operator void. Okay, which just has a C out of F. And then we instantiate S. We cast S to void. Now, this is a casting operator. The question is this gonna work? Like, is this gonna print F? Actually, all of them are kind of, these two are casting. One is the kind of a C cast, one is static cast, and one is just, okay, I'm actually calling explicitly the operator void.
Clear.
So the question is the standard allowing us to do such conversion, either C or static cast with void? And if yes, so yeah, we'll get 3 Fs, because this is, let's say that everyone agreed that this would work.
Yeah, if it compiles. And
it compiles,
does,
and it should work, right? I'm just explicitly calling the operator. I'm not casting. This is a function. It looks weird the way we call it, but it's a valid call. The question, so we know that 1 F happens from here. The question is, are these allowed? So let's just try with 1 F. If it works, it means that these two are not allowed, and then we can go back and see start 2 Fs and maybe 3 Fs. Okay, so this worked. Okay, why? S is converted to void in 3 ways. The last one is pretty much straightforward. It's just a function call. Okay, the other two are actually casting. According to the CPP standard, conversion function will never be used to convert an object to void. So the conversion function is only called once when we manually call it from S operator void, which again should always work. Now I'm gonna have a small detour because it's kind of an interesting point about casting to void and all. So I'll have a small detour just to learn something. So give me a sec. I'm gonna go back to my slides. I'm gonna share it 1 second. Let me know when you see it. Okay, do you see it?
Yeah.
Perfect. So once upon a time, someone wanted to do something like this. So there is some function, being a template function, and this person wanted to just have this variatic template, which we got in CppQuiz 11. We wanted to call print int multiple times. It doesn't work. You see that it doesn't work. Okay. Anyone familiar with variatic? Like probably some of you very familiar with variatic templates. Probably you saw all kinds of code that takes a specific expression and with variatic template kind of duplicating that. So this works with a specific modifications. In CppQuiz 17, it's really easy with fold expression, and we talked about fold expression like long time ago. By the way, this is exactly 3 years since we started the meetup. I think I started at February 2020, if I'm not mistaken. So CppQuiz 11 and 14, we didn't have fold expression. So you usually see this. Okay, so you have this variatic template, and then initialize a list where you take print int, you use void, so you can't really, so whatever, let's say print int returns an object. And let's say that this object is implementing operator void. Okay, so by casting it to void, we make sure that this operator void is not gonna triggered. This is just a trick that people use. We have (0) just to have all zeros. It's very clunky solution. The better solution is having fold expression. This is in CppQuiz 17. But I just wanted to highlight that this, if you're looking at old Stack Overflow and you see this void is actually related to, we are not going to have any overload void triggered by casting it to void. So that's one way to kind of make sure it's not happening.
I actually don't understand this. If you didn't have the void cast there, is the purpose of the void cast to avoid the operator comma from being invoked?
Yes, exactly. That's the next thing. Someone said something? I thought someone wanted to have a comment.
I think I just said okay and unmuted and moved back.
Okay. Yes. And there are more information if you just Google on Stack Overflow. There's like millions of these kind of answers. So yeah, so this is basically related to the comma operator, which cannot be overloaded. Okay, so this would be the most straightforward one with fold expression without this other syntax that is kind of clunky. Okay, so the last one that I would like to discuss is V19. Okay, so let's go back here. Okay, so this would be the last one before we go to the next topic. What is the output of this program? Okay, we have this lambda, which is basically we assign it to L. L is a function. We pass true or false, and then according to the flag, either we have A, instance of A, or instance of B, and we just call foo. So first of all, we have instantiation, so it's going to be either A or B, and we have a copy constructor. Sorry, it's not a copy constructor. We have a constructor that takes A. So basically, if I have, it's kind of a conversion constructor where if I have an A, and our value A would fit here because we have a const reference, then I can create a B. instance. Okay. So first of all, what do you think about this ternary operator? Like, is it kosher? Is it gonna be? Is it gonna work? If yes, why? The important part of ternary operator is like the two branches. They either need to be the same type or convertible. You can have different types. So is this fine? Is this gonna compile? There are two different distinct types, but is it gonna compile even if they are distinct types? And if yes, why? And I hinted that. Can we take A and create B?
Yeah, via that converting constructor.
We have a converting. So this is, first of all, this is kosher. Like if we didn't have this, we have two distinct, like, so this would not work. Like the compiler said, okay, what is the return value? Is it A or is it B? So we can take A and make it B. So it's B. Okay, so now let's see what happens with L true.foo. Okay, so L true is this one. Create an A. Okay, so we're creating an A. Okay. What else? What happens next?
And we call foo, so we get a 1.
Okay.
If the return type is gonna be B, maybe it'll get converted to B.
Okay, so it's B.
That'll be.
Now we are B.
Oh, right. Yeah, okay.
And then
now
1.
We are B. Wait a sec. We are B. We are not A anymore. We are B.
Yeah, so
it's not B, it's not A, it's actually like we already converted. We are a different instance.
Right.
Okay. So we 2. Okay, so A, B, and 2. It's very confusing, but again, the takeaway here is that we understand how conversion are happening here. We could avoid that, by the way, if we put here a specific keyword, but we don't have it. What is the keyword in order to avoid this implicit conversion?
Explicit.
Okay. So, by the way, I'm always having explicit in my constructor, so especially the single parameter ones, and it helps a lot to make sure that I don't have implicit conversion. Okay, the next one would be false, which is B, and then 2. So we already went through the process. It is a confusing part, but a few things I want you to kind of remember, takeaways. Ternary operator is really important that we have a common return type, either the same one or something that is convertible, which we have here. This is not explicit constructor. It is a conversion constructor, so we can take A and create a B instance. Once we create a B instance, we're not A anymore, we are B. This is why we have the results the way it is. Okay.
I would add one other little intuition check on that question, which is that the lambda, which is had an auto parameter and an auto return value, could not possibly, or auto return type, could not possibly have a different return type if the parameter type is the same Boolean in both cases.
Right.
Just another way of just double checking that your head is on straight.
Okay, so I'm switching to this new, so this is the new slide. Hopefully you can see that. Okay, so I bumped into a very interesting Stack Overflow, and I think we can learn a lot from few elements of this question. So the question is the following: I have this class object. It is a final class. Doesn't really matter. It's not a. It's just a kind of a habit of the author to have final, and we have 2 constructors. One takes Boolean. Just set the type to a specific number so we can just print it, and and it's marked as 1. And then we have a const by value stud function that takes a pointer and pointer to an int, and it returns an integer. Okay, and this set the type to be 11. This is number marked as number 2, and then just return type, which is used here to print. And the person that opens the question says, I want to call number 2 through object print line. Okay, and print line, someone coming from Rust, and then instead of object stud function, but the result is that number 1 is called. So basically, the question is like, why stud function is converted to bool. So take a few minutes before we dive into that and tell me what do you think about it. So the results are printed here. So when we have print, it's actually here, goes here. Stud function goes here. So stud function it's a perfect fit. It goes here, but print line is actually go here. And the person wants to call number 2 through this print line, but it goes to Boolean.
It's kind of at the end. It's a function pointer, so in pointers can be
it's converted to Boolean. Yeah. So so let's take a quick dive. Like one option, if like how to fix it. So one option is we could actually reach out. If you are lucky enough to use CppQuiz 20, we could reach out to concept. And we had at least one session on concept some time back, maybe a year ago. Martin had a session on that. And the idea is pretty simple. There is a concept already for us named, you see this concept invocable. So so this is the way, this is the syntax, invocable auto, and then both of them would be 11. This is a better match than the Boolean one. So even the print line would do that. So if you have the ability to use concepts, this is a good option. But this is not the only option for you if you don't have concept. Actually, just today I had this exact same, not exactly the same, but I had a similar use case where I would love to reach into concept, and I couldn't because I'm on 17 and not 20. But in some sense, I would say almost maybe everything, but at least almost everything that is expressed in concept can be also expressed with another construct. Anyone knows what? What could be in 17 and before? Instead of concept, there is another way to do stuff where you can remove overloads according to the type in compile time.
Would it be explicit?
Not explicit. There's another one that you can enable or disable things. Enable if. So enable if is not new. So it's something that we had long time ago. It just the library is providing this today, these days. It used to be something that we need to handcraft ourselves. It's something that is built on regular template mechanism named Sphena. Substitution failure is not an error. It looks ugly, and what I understood from some people from the committee is that the concept should have been a more closer to what we have in Rust in terms of interfaces and traits, but we got something which is a more convenient enable if syntax. Okay, so let's take a look what we have here. So first of all, we left this boolean as is. The idea is how do we replicate this invocable here with enable if. We don't have that. So we're reaching out to enable if. So this is a function that returns. This is it's a function. It's a constructor, and what we do is we take we use template f in this case, and then forget about the type name for a second. It's a bit confusing, and let's focus on the is convertible. Convertible v is basically a syntactic sugar that we got in C +14, most of it. Actually, is convertible v we got in C +17. Most of the underscore v we got in 14, but this specific was 17. Not everything was in 14. So is convertible is a type trait. It's a type trait, and instead of : v at the end to get the value, which is here, we can do underscore v. So we check if f is convertible to stud function, and f is a parameter to the constructor. Now, we don't really need the type that is returned from the enable if. So this whole enable if returns a type if the f that we're passing this can be an f, this can be an f. If the f that we're passing is convertible to stud function, which is int star int, then we get a boolean as a type. So if this is evaluated to true, if from this stud is converted all the way to here, is convertible is evaluated to true, we get boolean. Otherwise, we have substitution failure. The compiler gives up. It doesn't instantiate for us this function. In this case, it's constructor, and it's just removed from the overload set. Since we don't care about it, we just equal to true, just to silence the compiler that if it is convertible to this function, we get a boolean as a type. It's like I have type name f and then another type equal to true. So like bool equal to true. So I don't need that because otherwise I would need to pass it here with another like template parameter. So this is why they equal true. So we end up with two options. Either this function would exist in the overload set, and it's going to exist if we send something, if f that is deduced is a function that has this signature. If not, nothing happened. This function never happened, and the only function that would exist would be this one. So this works, and this works because when we have this when we set this argument to this parameter, it is f. F goes here. It is convertible. We get boolean equal true just to silence the compiler. We don't need to pass another template parameter, and this function is part of the overload set. It's a better match than boolean, and we are done. So I actually had the opportunity to use enable if today because we didn't have concept. I took code that was like, I don't know, 15, 20 functions, made it templates with few lines, just with enable if, just to get that shortened. But with concept, it would be even shorter syntax for me. But it is a very handy. It's kind of more on the advanced side, but it is a very handy tool that you can reach out to if you need to. Okay. Any questions regarding this? No. Okay. something easy. Polymorphic arrays. So there was a question why this is not working. Okay, so we have a class A. It's a very, by the way, it's a very common issue. We have this class A. It has a virtual destructor and a member, m_t, and then we inherit from A publicly. So B can be converted to A. And same deal. We don't really like this is there's lots of code is redundant here. We don't need the constructor. We don't need this destructor is kind of redundant, and this could be equal default. But forget about this tiny details. We have a pointer. We new B, and then we delete the pointer. We do the right thing since we have new of using the array like brackets. We do the delete in the right way, but this is not working. Why it is not working? What do you think? Why polymorphic arrays doesn't work? First of all, do you agree that it's not working? This person says it deleted destructors, no exceptions. Any guess why it's not this is not working?
I would give a hint. Try imagining the destructors getting invoked on the array members and what happens.
Yeah, they are. First of all, do you agree they are different size? B and A are different size, right? So when we have pointer to an array of A, there is no information about A is actually pointing to something else, and I have a slide on that. But first of all, let's try to use sanitizers. So let's try address sanitizers. Address sanitizer would give us this. So first of all, there is an issue, and it is pretty much easy to see that there is an issue. It's not just something that is kosher. It's really an issue, and if you just put it on any debugger, you'll see also this issue. So let's take a look here. For example, I have this. I just took the same question. I just made it a bit more fancy. So I have this A, which has a function, virtual function. I have F here. It's overriding A and B. And I have a function. Once I have this array, I have a function that I'm passing the pointer. So when I have this array bracket 3, what actually happens? What do you, this is not even C++, this is a C thing. What is array 3?
Just goes to the third location of whatever the size of the
Yeah, it's a pointer arithmetic. That's it, right? So do we actually, what do we have here? Do we actually have A or do we have B? We have B. So the compiler, when it prepared the code, it's actually doing this array. Remember, it's a 3, it's just an offset, right? So and it's pointer arithmetic. So it's whatever the size of A, it goes, but it's not in the guts of this memory. It's not A, it's B. So if I going back here, this is 0, 1, 2, and 3. So I'll be here trying to do something, trying to access memory, which is like doesn't make sense. It's not aligned to B. This is not the right element. So it's a very common kind of. I think it's it is a common thing that people would try to have a polymorphic simple arrays, and it just doesn't work because of this exactly this reasons. It's kind of confusing part because there are some ways where we can actually achieve something similar. So let's take a look at how we can do something which is kind of more conforming. Same deal, and let's take a look at multiple use cases. So we have a vector A and new B, new A. Okay, so what happens here? What do you think?
Vector's just storing pointers to the
yeah,
objects
it's just
itself.
pointing exactly. It's just storing pointers. There is no the pointing arithmetic here is correct, right? I'm storing A, and this is just a regular virtual polymorphic approach. There is nothing fancy here that works. It's different from this one, right? Because I have this different array that I'm passing over, and when I do arithmetic on that one, it's different. Okay, and do you see the difference between these two? Is there any question? Okay. So what about this one? I want to pass v1.data to here. Is this gonna work? It's not working. It goes back to the same issue. There is a pointer arithmetic that doesn't work well, right? You agree
There
on
you're
that?
not. You're just passing an object pointer. So yeah.
Yeah. So okay. So next one. How about this one? This unique pointer. This unique pointer is basically the same as having instead of new, it's having that, and this works fine. Like v2.font would give me the font, and I have f, and polymorphic works perfectly here. This doesn't compile. Why? Because v2.data doesn't provide me the raw pointer. It's a unique pointer which doesn't convert to a pointer. This is fine. Do you see the difference between what I had before and this one?
It's B.
It's B. Yeah.
B, yeah.
It's B. So the delete would do the right thing because we have the correct size. This would also work. Like I'm not using unique pointer for allocating arrays usually, but I've seen that happen in code bases. So that's also, I prefer vector because I have everything encapsulated. But sometimes we do need such syntax. This works well. Both of them are B. This doesn't work. I cannot have a make unique that is pointing to A here. That's not working actually. So going back to the previous, the original one, they having make unique of B, like 10 Bs, assigning to A just doesn't work. So that's what I actually wanted to kind of make sure that people are aware of. Like polymorphic arrays are tricky. Use different mechanisms in order to have that working. Is there any question? Okay, people understand the difference between this one and the original one, right? Okay, awesome.
Presumably.
Sorry?
Presumably.
Presumably? Okay, if you
Can't
have
read it.
questions, if you have doubts, let's discuss it.
Just a quick question.
Sure.
So in the first failing case, right? If you do a dynamic cast, would that work?
The first one. Right, said this one. Or just the original one, this one.
Inside the function, the next go to the next one. Yeah, here. So inside in line 18. So there, if you did a dynamic cast.
So
I mean, it's not a clean way, but just I'm saying, will it still work or not?
So the problem, yeah, the problem here is that I don't believe it's gonna work anyway, because the pointer arithmetic points to some location in memory, and you don't have the boundaries of B. Okay, so the vector part is that every pointer is actually pointing to a B, an allocated B. This is not the case here. It's like, it's a very kind of, I take a memory of B, which are 5, and I assign it to a pointer of A. So you can see that are not aligned. Like, it's a very different memory layout. In the
I guess
vector,
because of the array.
Yeah,
sure.
Exactly. So this is the image that I want everyone to kind of picture, because it's just I'm allocating this amount of memory and assigning it to this one. Once I assign it to this one, I'm losing the information that it's B. Every pointing arithmetic would do this. In the stud vector part, what I have is this memory, and I have pointers to an allocated B's. So try to imagine. So in the vector part, there's a pointer of A here that points to an allocated B. Okay, so the memory is like this. The memory layout in vector is like this. Okay, the data. So this one would point here, and so no matter what, like what is the pointer arithmetic that I'm gonna do with vector, whatever I'm touching has a pointer that directly points to a specific. This is not what I did here.
Right.
Kobe, one question. Like,
yeah,
if instead of int x in B, we used UN64 or something like that, would we get lucky? I think we could get lucky in that case, right?
Oh yeah,
I mean,
you
it's
can
still not
always
good
get
code,
lucky.
but I'm just saying.
Yeah, you can always get lucky, of course. They deliberately took something which is bigger.
Mismatching, yeah. Mismatching
Because
in the size.
this one, yeah, B is A plus int.
Right.
So this is why I wanted to point that one. So this is like, I could have an array of 5 pointers of A, and each of them I would do new B. That's a whole different story, right? That's a whole different story, because this is not the same as this one. This is the one contiguous memory of B's, and then I assign it to a pointer that points to A. This is not the same layout, and the pointer arithmetic would be different. So actually, what I want to highlight is the pointer arithmetic is very important in this case.
Kobe, one more question then.
Yeah.
Is there any difference between the standard array? Would that still have the same problem?
Standard array, if you assign pointers that they have this different layout, yes. Different layout, yes. Standard array is an aggregate, then unless I'm missing something and I don't see the entire picture, I believe that we need to type it in order to make sure that we're talking about the same thing. But I don't see
no.
any.
There is in STL, there is just like there's vector, there's also standard array, right?
Yeah, the std array. Yeah, I'm talking about the std array.
That's the one I'm talking about.
It's an aggregate. It's an aggregate type. So
you wouldn't be able to actually like convert one type to another because it just won't compile.
Yeah, there are two different types because of the templates. No, I think what he's saying is that the data, if you mix the data, but I'm trying to think, how would I do that? I can't think of a way, because the std array is actually, when you say, okay, 5 is a contiguous memory. Yeah, like it's gonna be tricky. I'm trying to think how I can trick it, but I can't really think about something like that right now. Okay, so we are 4 minutes to 6. So I have one thing which is really nice. So let's take a look at it, and then we'll conclude this session for today. Sorry, I do need to stop around 6. So there is a very nice Stack Overflow that we can learn a lot. Why does removing const from this constructor parameter stop the class from being instantiated? Okay, so we have this following. We have a struct de. We have a struct hack. Struct hack has two constructors. One that takes de, which is just a struct, non-const by value. We have another constructor that take what, which is a class, a template class, or class template to be exact, const by reference. And the way it works is that this class, when it's instantiated, it's static assert, because this const expr always returns false. So this static assert would always fail as long as you instantiate this what class. And in main, we have the following. We have an instance of de. Then we pass this de to heck. Sorry, that's not my question. What the heck? Okay, so we pass de to heck. Okay, so there are two constructors that we could use. One is the first one, looks perfect, very kind of a great match because it accepts the type, and I'm passing there. And then there is another one, what? The question is why? So this is when we have this code as is, the assert is triggering, which means that this class is instantiated. But removing const, it stops what int from being instantiated, hence it's not failing. So just removing the const here, pass the program. Why it's happening?
I'll try to give an answer.
Yeah,
well,
give it an answer.
Else wants to go, since
it's actually
there's no
related
time
to something. Yeah, go ahead. There's always time.
Basically, like if it's a non-const reference, you couldn't have a non-const reference become if through any kind of implicit conversion, like be pointing to something, because the only thing it could point to is the variable, and that's just not gonna. There's no way that would work. So it's not even gonna consider instantiating what if it's not const.
Okay, this is really on the right direction. So I'm gonna continue what you're saying. In order to convert something to something, I'm gonna get an R value, right? Everyone agree on that one? I need to convert something. I'm gonna create an R value, and then I'm gonna pass it. When I create an R value and I want to pass it, there are a few ways that the code would be accepted. One way is I can pass it to a parameter that is a const reference, because const reference can bind to an R value. Okay, it's kind of on the advanced side, but bear with me for a second. Everyone agreed that const reference can take a temporary or an R value. So which means that if we have a const reference, the compiler can say, okay, I have this day, maybe what of int has a conversion constructor. Again, we're going back to one of the things that we talked about. Maybe it has a conversion constructor. In order to check if there is a conversion constructor, I need to instantiate this what class. So I'm going to instantiate the class. I'm going to check if there is a conversion constructor. If yes, fine. If no, I'm dropping that and I'm moving on to the next candidate. So since I have a const reference, as a compiler, I'm confident that if I have a conversion, so I'm getting a temporary, I can pass the temporary to this constructor, the heck constructor. But if I remove const, I cannot do it as a compiler. The rules is that this temporary cannot bind to a non-const reference. Hence, the compiler is not going to instantiate what in the case that there is no const. Does it make sense? That's basically, there's a few things. First of all, we're going back to the conversion constructors. The compiler doesn't know until it's instantiated. It's a template. Until it's instantiated, it doesn't know if there is something in what that they can take a heck and give me what back. So I need to instantiate. Since I have a const reference and I'm gonna create a temporary instantiated from what, I can do that only if I have a const. If I don't have a const, I'm not bothering even to instantiate. This is why removing the const, not instantiating what, and the static assert is not triggering. So that basically what happens here. And I'm explaining this here, so you can take a moment and read it, or you can also read it from like offline. This is what happened when hack get const of what of int. If we pass that, which is an instance of that type, does what has an implicit constructor that takes the, again, needs to be implicit constructor. So in order to do that, we need to instantiate. Otherwise, if we remove the const, we don't bother to do that, since there is no point of creating a temporary and trying to pass it as an argument to a non-const reference, because it's not going to bind. So there is no point to do that. But there is a wrinkle. So this is basically the answer. There is a wrinkle. There is one wrinkle to that. Anyone can think about kind of a more advanced part of like why do we actually need to instantiate what in the first place? What do you think? Do we really need to instantiate what while we have this heck there as a constructor competing with this constructor? What do you think? And it's actually written here on the slide. So another takeaway from today is conversions. Basically, and it's written in the answer, since the second part is a user-defined conversion, and the first constructor is a perfect match, no conversion at all. It's one-to-one. It's a better match, and essentially we don't really need to instantiate what at all, no matter if it's a const or non-const reference. Actually, we don't need to instantiate. So there might, I think one of the compiler that was asked in the question was doing that, where it shouldn't actually do any instantiation. What I want you to remember is that when you have in front of you a case where you might instantiate, so you have a candidate, one of them is a perfect match and one of them needs a user-defined conversion. The user-defined conversion is kind of a non-first class citizen. It's a second class citizen. The best match is a first class citizen. It would win. So after all this explanation, one of the takeaways that the compiler that actually did instantiate with the const didn't even need to instantiate it. So it's kind of a non-conforming compiler in this sense. So there is some explanation here. Is there any question regarding that specific, like what I just said about conversion and what happened here? Anything that you would like to comment?
Oh, I have a question if you know. So is it actually the case that like the C++ standard defines that this class will be instantiated if even though it can't actually be considered? Or is that just a compiler behavior?
So let's start from the end. My understanding is that the compiler, a conforming compiler should not, and some of them would not, by the way. A conforming compiler should not even instantiate that because this is a user-defined conversion. Let's say that
okay.
we let's say we can.
I zoned out while you were explaining this. I don't need a full explanation. I just wanted to
Okay.
Thank you.
Okay, we're welcome. That really the takeaway is I want you to remember explicit versus implicit constructors, conversions, user conversions versus non-conversion perfect match. All of that are very important when you write code and you design your API. So you want to make sure that it's easy to use and there are no surprises. This is a surprise with one compiler, but should not happen. Okay, so I had another slide with Wonderfox, but I think I'll do it next time because it's already 6:07. Anything that someone wants to mention before we close the session today? No? Okay. Thanks for everyone for attending. Have a good rest of your night and take care.
Thank you.
Thank you, Kobe.
Thank you.
Thanks.
Thank you.
Thanks. Bye-bye.
Thanks,
Very useful. Right, bye.
Thanks, Kobe. Thanks, Kobe. Bye.
Thanks, everybody.